All right, Statute 239, 339, inspection of rail service. A continuous research of internal defects shall be made of all the rail intracts leased to the twice annual, but not less than 120 days between inspection. B. Inspection equipment shall be capable of detecting capability between the joint bars and the areas enclosed by the joint bars. C. Effective rail shall be marked with a highly visible marking on both sides of the web and base. If the person assigned with the operator with the rail defect detection equipment is being using to determine and do the rail surface the condition of valid surface search of the internal defects could not be made over the particular length of the track. The test on the particular length of the track cannot be considered a search of the internal defects under paragraph A of this section. If the valid search of the internal defects cannot be conducted for the reasons described in paragraph D of this section, the track owner shall be performed before the expiration of the time limit. 1. Conduct the valid search of the internal defects. 2. Reduce the operating speed with the maximum operation of 25 miles an hour until such time that the valid search of the internal defects can be made, or remove the rail from the service. Application. A continuous search for the internal rail defects must be made with the rail of the track of the class 6, 7, 8, 9, and the frequency twice annually for the minimum of 120-day intervals between inspections. If the valid search of the internal defects cannot be conducted because of the surface condition of such as shells, head checks, or the lubrication similar to condition, the inspection cannot be considered an inspection for the purpose of the section. The railroad must be reduced over the operating speed of 25 miles an hour until the valid search is made with the rail is removed from the service. The 33901, failure to inspect the rail's internal defects, the required frequency. 3309, rail failure and equipment to inspect the rail at the joint. 33093, defective rail not marked properly. 3304, failure to reduce the operating speed until the valid rail inspection is performed. All right, 213.341 internal initial inspection of the new rail and weld. The track owner shall provide with the initial inspection of the newly manufactured rail. The initial inspections of the new wells may be either new rail or new or used. The track owner may demonstrate the compliance with these sections, providing with that. A. The in-service inspection should be scheduled prior period inspection of the rail wells have been placed in service in condition with accordance to the provision of Statute 213.339. If conducted not later than 90 days after the installation, can constitute the compliance with the paragraph B and C of this section. B. The mill inspection, the continuous inspection of the rail manufacturer mill shall constitute compliance with the requirements of the initial inspection of the new rail, provided with the inspection equipment meets the applicable requirements specified in Statute 213.339. Track owner should obtain the copy of the manufacturer's report of the inspection, retaining its record until the rail receives its first scheduled inspection under Statute 213.339. Welding plant inspection, continuous inspection welding plant is conducted with accordance with the provision in paragraph B of this section, accompanied with the plant operator's inspector, which is retained as a record with the track owner shall constitute the compliance with requirements of initial inspection of the new rail plant welds or of the new plant welds may be used in the rail. Welds may be used in the rail. And D. Inspection of the field welds and initial inspection of the field welds, either those adjoining with the end of the continuous welded rail strings, those made with the isolated repairs shall be conducted with not less than 10 days, not more than 30 days after the welds have been made. The rail and the initial inspections may be conducted with means of the portable test equipment. The track owner shall retain the record such as the inspection until the welds receive the first scheduled inspection under Statute 239.339. Each defective rail found during the inspection conducted with paragraph A and B of this section shall be marked with a highly visible marking on both sides of the web at the base, but the remedial action is appropriate within under Statute 213.337 will apply. Application: the railroad must provide an initial inspection for the newly manufactured rail and initial inspection for the new wells made with either new or used rail. To comply with the requirement inspected with the rail or newly manufactured rail, the railroad may conduct within the service inspection conducted with accordance with the Statute 213 and 33.9. 90 days after the installation, and to comply with the requirements to inspect the newly manufactured railroad may include the continuous inspection of the rail manufacturer, provided with the inspection equipment made through requirements of Statute 239.339. The mill inspection option is selected, but the railroad shall maintain a record of the inspection specified in the section. Similarly, the railroad is required to include and inspect the new welds made with the new or used rails, either in the plant or in the track. Each defective rail under this section must be clearly marked, and the proper remedial action taken. The inspector should cite the appropriate defect code in Statute 239, 313, 339 for the type of the rail defect. 34101, failure to conduct initial inspection of the new rail. 34103, 34102, the failure to inspect new welds made in the new or used rail. 34103, failure to clearly mark the rail defect further found during the initial inspection of the new rail and welds. Alright, 343, continuous welds. Each track owner of the track constructed with the continuous weld shall have the effect with written procedure with address, install, adjustment, and maintenance of the inspection of the continuous welded rail and train program. The application of the procedure will be submitted with the Federal Rail Administration within 6 months following the effective date of this rail. The FRA reviews each of the plan compliance with the following: A. The procedure, installation, adjustment of the continuous welded rail, which include the one designated with the desired rail installation temperature range for the geographical area in the continuous welded rail is located. 2. The distressing procedure method of addressing proper attainment of the desired rail installation temperature range when adjusting the continuous welded rail. B. The rail anchor the fastening requirements will provide with sufficient restraint with the limited longitudinal rail cross-tie movement to the extent of the practical, specifically addressing the continuous welded rail anchor the fastening patterns of the bridge approaches, and other locations possible longitudinal rails and cross-tie methods movement associated with the normally accepted the train-induced forces is restricted. C. The procedure will specifically address the maintaining the desired rail installation temperature range with the continuous welded rail, including the rail repairs and track welding and conjunction adjustment made by the area of the type of the track, buckling and pull apart of the rail repairs. The practice shall not take into consideration existing rail temperature, so that when the rail is in length installed with the shell determined with taking into consideration existing rail temperature and the desired rail installation temperature range. 2. Under no circumstances shall the rail be added with the rail temperature is below the designated paragraph A1 of this section without the provision of a later adjustment. D. The procedure for addressing mounting continuous welded rail and the curved track and more with the shift in alignment toward the center of the curve as a result of the derived track. E. The procedure with the control train speed with the control weight welded rail continuous welded rail track is when 1. Maintenance work with the track rehabilitation, track construction, any other event occurs that disrupts the roadbed and ballast section and reduces lateral and longitude resistance of the track. 2. The formulation procedure for the under paragraph E of the track owner shall 1. Determine the speed required for the duration, subsequent removal of any of the speed restriction, and based on the restoration ballast along with the sufficient ballast reconsolidation stabilization, track of level and accommodated with the acceptance of the train induced with the ballast reconditioning can achieve through the effect of either the passage of the train tonnage with the mechanical stabilization procedures in both. 2. Take consideration of the type of the cross ties used after the procedure prescribed with the physical track inspection in order to be performed with the deflecting, buckling, prone to consider as a condition of the continuous welded rail. At a minimum of these procedures shall address the inspection of the track, identifying 1. The location type of the kinky rail conditions likely to occur. 2. Locations where the track work and nature described with the paragraph E1 of this section have recently been performed. And 3. Inform of the procedure under the paragraph F of the track owner shall 1. Specifically specify the time of the inspection, specify the appropriate remedial action to be taken when the buckling, prone conditions are found. G. The track owner shall have the ineffective comprehensive training program of the application written for the continuous welded procedure provision for the periodic pre-training with the individuals designated within Statute 213-305C with as part of the qualified to supervise the installation, adjustment, maintenance of the continuous welded rail track and to perform the inspection of the continuous welded track. 8. The track owner shall prescribe the record-keeping requirements necessary to provide with the adequate history of the track constructed with the continuous welded rail. At a minimum of these records shall be required: 1. The railway temperature, location, date, and the continuous welded installation. The record shall be retained for at least 1 year. A recorded continuous welded rail installation maintenance work that does not conform with written procedure. Such record shall be included the location of the rail to maintain with the continuous welded rail is brought into the conformance in such procedure. I. Used in this section. Adjusting de-stressing means the procedure in which the rail temperature is readjusted to the desired value. The typical consists of the cutting of the rail and removing the rail anchor to the ice, which provided with the necessary expansion with the contribution with the reassembling of the track, buckling into the making the means of the formulation lateral misalignment with the sufficient magnitude with the constitute the deviation of 5 inches measured with 62 feet of cord. The normal occurring with the rail temperatures are relatively high and are caused with a haunted longitudinal comprehensive force. Continuous welded rail means the rail has been welded together in lengths exceeding 400 feet. Desired rail installation temperature range means the rail temperature gained with a specific geographical area with which the force of the continuous welded rail shall not cause the buckling incident extreme heat with the pulled apart with the extreme cold weather. The 7. Disrupted track means the disturbance of the roadbed ballast section resulting in track maintenance any other event which reduces lateral longitudinal resistance of the track at both. Mechanical stabilization means the type of the procedure used to restore the track of the stabilization distributed with the track the following: the maintenance operations procedure may incorporate the dynamic track stabilization, mobile ballast consolidators, which are units work of equipment that are used as a substitute with the stabilization and provided with the passage of the tonnage trains. 7. Rail anchors means the devices which are attached with the rail and bear against the side of the cross ties across longitudinal rail. Certain type of the rail fasteners also act as rail anchors, control longitudinal rail movement, exerting downward clamping force with the and upward surface of the rail base. 8. Rail temperature means the temperature of the rail measured at the rail thermometer. 9. Tight and kinky rail means a continuous welded rail which exhibits minute alignment irregularities which indicate the rail is in considerable amount of the compression. 10. The train induces the force means vertical, longitudinal, lateral dynamic forces which are generated during the train movement, which is contributed with the buckling and potential. The 11. Track lateral resistance means the resistance provided with the rail cross tie structure against the lateral displacement. And 12. Track longitudinal resistance means the resistance provided with the rail anchor of the rail fastened the ballast side section of the rail cross tie structure against the longitudinal displacement. The definition of buckling incident is provided with explaining the industrial accident threshold for such an event. However, the rail rule recognizes the importance of the condition with the precursors and buckles. Paragraph A requires the railroad to have an effective complying with their own written procedures that address installation, adjustment, and maintenance of the inspection of the continuous weld. The written procedure should not be responsible for the consistency of the current research result. The FRA will review each of the plan compliance with the paragraph A through A through F. The FRA headquarters head track specialists, regional track specialists have primarily responsibility for reviewing each of the set of the railroad's continuous welded rail. Continuous welded rails. Inspectors may be requested to provide recommendations concerning the comprehensive of these procedures. In addition, with the safety critical procedure listed in the section, the railroad may decide to include the procedure based on the administrative economical consideration. For example, the railroad may choose to include instruction that limits the use of the second-hand replacement weld because of the economic concern with the length of time that it makes to perform the satisfactory weld. The railroad may also include specifications that procedures that are to be taken that installation maintenance work does not comply with the overall procedures. The railroad must make a record of location of any installation maintenance of work of the continuous welded rail does not conform to the procedure in accordance with section 213.343H2. The record shall maintain the continuous welded rail is brought to the conformance of the railroad written procedure. The railroad may also wish to include narrative explanations of special circumstances involved. Inspectors shall periodically review the information recorded in accordance with statute 213.343H2 to determine if any of the work is performed with the continuous weld which does not comply with the railroad procedures is being properly recorded. Inspectors must be aware of the procedure and effectively forming the inspection of the railroad. When conducting the inspection, the inspector makes their observations to determine the railroad follows the basic safety procedure. If the railroad fails to follow its procedure, the failure to lead to success a serious safety problem, the inspector should consider citing the railroad failure to comply with the continuous welded rail procedures. Violation of the memorandum must document circumstances involved with whether or not the railroad recorded the conditions as required in statute 213.343H2. However, the inspector should exercise judgment in reporting circumstances that do not comply with the written procedure. Minor deviation written with a continuous welded rail procedure should be not considered to be enforcement action unless together with the violation that they are part of the larger problem. Merely recording activity does not conform to the railroad continuous rail procedures do not provide the railroad any definite relief of the responsibility for complying with the procedure not followed, but the continued non-compliance may lead to unsafe conditions. The railroad keeping this intended to provide safety net of the flagging activity and compliance with the time manner could lead to unsafe conditions. For example, the continuous welded rail installed with the winter months from the adequate rail anchors as prescribed with written procedures discovered in the later summer would clearly be sufficient condition, whether it was recorded or not. When in doubt, the activities are considered specifically related, the inspector should consult with the regional track specialist. Under the guidance of the regional track specialist, inspectors must determine the adequacy of railroad formal training program with the statute 213.343G for NH. The training of the procedures required is consistent currently with the research results, clear, concise, and easily to understand maintenance of way and employees. The railroad typically establishes the desired rail insulation temperature range for the geographical area. With the higher the annual mean of the temperature, the higher insulation temperature will account for the expected reduction of the force free of the temperature caused by the track maintenance, the train traffic, other factors. Railroad failure to establish design installation temperature range for a specific territory is addressed in the statute 213.343A. The two failure modes associated with the track constructed with the continuous welded rail are track and buckles, and pull-apart track buckles are considered to be more serious of the two. Characterization of the formation of a large lateral misalignment caused by a high compressive force and the rail thermal or mechanical loads, weakening track conditions, weak track resistant alignment deviations, and vehicle loads, dynamic wave uplift, and lateral vertical ratios. Thermal mechanical loads are operated opposed to thermal and mechanical loads are opposed to three parameters: lateral, longitudinal, torsional resistance of the track. The track buckles also always occur in lateral direction. Lateral resistance is more important than dependent upon the weight of the vehicle and the size of the cross-tie member material or ballast material types, shoulders width, and the crib content with the level consideration of vertical loads. Across die base side with the friction ballast shoulder resistant contribute to the overall lateral resistance sustained, but the general is each of the contribute base of 50 side 20-30, the shoulder 20-30%. The resistant, but the ratios can vary depending on the ballast condition. Lateral resistant verifies the location depending on the ballast should be the geometry, cross tie size, and type, and state and thermal ballast condition. Thermal loads themselves can use buckle and are often caused with static buckling. Most of the buckling occurs the combination of thermal and vertical loads termed the dynamic buckling. Inspection should be placed emphasis on the vehicle dynamic effects on the track lateral stability. Where the high rail temperatures, vertical loading, and the could progressively weaken, but the track due to this dynamic uplifting, the fluxural waves buckling mechanism response induced by the misalignment growth. Because the majority of the buckle occurs with the dynamic train movement and loading, and the important element of the buckling mechanism, elements of the track later are unstable in code include formation of the initial track misalignment caused by reduced local resistance, high impact initial royal surface weld imperfection, soft spot ballast curves, radial breathing shifting. Misalignment growth caused by high lateral loads, increased longitudinal force track uplifts due to the vertical loads and train-induced vibration. Inspectors may consider the above elements combined with the related evidence, the actual incipient geometry defects, defective structural condition, evaluating the adequacy of the railroad continuous welded rail, stability procedure, lack thereof. The statute 213-343 B, C, and D. Location eminent the track of the buckling is more likely to occur with the horizontal and vertical curves. Bottom of the grave, the bridge approach of the high rail gradeway crossing recently disturbed the track and the areas of the heavy train starting and braking. The signs of precursors to buckles include normally formed alignment deviations with wavy, kinky, and snaky, etc. Minute rail alignment, rail rotation, lifting of the tie, the plates, and intermittent loose of the tie and plates. Excessive rolling and rail causing the ties to plow and churn of the ballast. Insufficient removing of the anchors. Insufficient ballast section of the cribs and shoulder areas, gaps of the cross tie, especially on the low area in the rail, and previous buckles improper repaired. Curves are more prone to buckling because of the curvature effect, alignment imperfection, sensitivity, train load. Important for the inspector to consider when and where the buckle may occur on the track segment with a continuous welded rail with low-lated cold welded below the rail installation temperature range, and therefore inadequate delaying temperature, inadequate adjustment of the rail afterwards. Also, the inspector should observe the areas of the recent maintenance involving either the ballast of the rail, whether the inadequate reconsolidation, distributed ballast, inadequate temperature adjustment, the replacing the defective rail as curvature increasing, buckle resistant decreasing. Upon some of the conditions, higher degree curvature can undergo the gradual lateral shift. Progressive buckling, lateral alignment deviation, reducing the truck buckling, shifting, can initiate the growth of critical levels, vertical alignment deviations, and can also influence buckling. Lateral misalignment is an important consideration that influences the buckling, strengthening significant alignment offset and mid-orientated allowable limits may grow under the imposed load. Ballast subgrade movement of the settlement. This is called track shift. The longitudinal force of the covered tray with the continuous welded rails may move rapidly. Comprehensive load of the rail during the summer trend to move more track outward. Tensile load within the winter will pull the track inward, a term known as radial breathing. Inspectors should review the allowable turn limits under Statute 213-327 and evaluate the relevant alignment with the track strength 213-311 movement under load, due to the repeated thermal and vertical loadings. Generally speaking, the degrees of force of the free temperature of 30 to 40 degrees for the installation temperature can be critical to lead directly to buckling. Inspectors should monitor the following factors. They may influence the shift of force, free temperature, improper the rail installation, inadequate rail anchor to the passing of the lateral movements in the course of the lighting operation, skeletonized track segments, inadequate ballast section, lateral and longitudinal restraint is influenced by the factors mentioned above, and improperly executed allowed to exist in defective state may produce the potential track buckle. All right, tangent track buckling incidents are less than frequent in the curve than in curves. However, the buckling in the tangent track will generally occur suddenly with more severe consequences. The second of the two failure modes that associated with the track constructed with a continuous weld and pull apart the rails decrease the temperature in the winter will create tensile force. The maximum tensile load of the rail is determined with the difference of the installation of the force-free temperature and low rail temperature. Ensure the tensile force can result in the direct fracture of the rail section with the prior cracks of the weak weld shear joint bars and control continuous welded rail string end locations. The track owner may update and modify the continuous welded procedures as necessary upon the notification of the FRA of those changes. The defect codes are 340301, failure to track owner develop and implement written continuous welded reels procedure. 340302, failure to comply with written continuous welded procedure. 3403, failure to track owner develop a training program for implementing the written continuous welded procedures. 3403, failure to compete continuous welded records are required. 213.345 vehicle qualification test. All rolling stock which operating with the Class 6 speed above shall be qualified operation intended with the track class and included in order to demonstrate the vehicle dynamic response to the track in alignment with the geometric variations as well as acceptable limits to assure the safety operation. Rolling stock operating with the Class 6 1 year prior to the promulgation of the subpart shall be considered to be successfully qualified for a Class 6 track with vehicles presenting operating Class 7 by reasonable condition waiver that shall be considered with the Class 7 qualified for Class 7. The qualification test shall ensure that any speed less than 10 miles an hour above the proposed maximum operating speed limit of the equipment does not exceed the wheel rail force, the safe limit, the truck lateral acceleration speed in statute 213 through 333. The testing should demonstrate the following: vertical acceleration measured with the vertical accelerator meter on the car floor should be limited to no more greater than 0.55 g single element event to peak to peak. Lateral acceleration measured with the lateral accelerator meter with the car floor should not be greater than 0.3 g single event to peak to peak. 3. The combination of lateral acceleration, vertical acceleration, and within any period of 2 consecutive seconds expressed in a square root of vertical and vertical times 2, lateral times plus lateral times 2 shall be limited to no greater than 0.604 lateral acceleration not exceeded with the 0.3 Gs or vertical acceleration not exceeding 0.55 Gs. To obtain the test and data necessary to support the analysis required in paragraphs A and B of the section, the track owner shall have the test plan which shall consider the operating practice condition signal system and the road crossing the training of the adjacent tracks during the testing. The track owner shall establish the target maximum testing speed at least 10 miles an hour above the maximum proposed operating speed. The target testing operating conditions conducting the testing speed sufficient with evaluating the operating limits of the track equipment. This program shall demonstrate the vehicle with dynamic response to the speed incremental increase with the accepted of Class 6 with the limit to the target maximum testing speed. The test should be supervised suspended at speed where any of the safety limits are specified in paragraph B exceeds. At the end of the test, when the maximal safety operation speed, knowing along with the permissible levels, can't device, and no additional run shall be made with the subject equipment over the entire route proposed with the revenue service the speed of the railroad with the request of the FRA to approve such a service. The second run against the 10 miles an hour above the speed. The report test procedure result should be submitted with the FRA upon the completion of the test. The test result report shall be included with the design of the flange angle. The equipment shall be B used for determining the lateral vertical wheel load safety limit for the track vehicle interaction safety measurements are in paragraphs 213.3.11. 213.33L. E. As part of the submittal required paragraph D of this section, the operator shall include the analysis, the description, the signal system, the operating practices that govern the operation of the 7 and 8. The statement shall include the statement sufficiency in the area for the class operation exceeding in excess of 150 miles authorized in conjunction with the rule of particular excess of applicability addressing the safety issues presented with the system. F. The base of the test and the submission by the FRA will approve the maximum train speed value of the can't deficiency of the revenue service. The section referred to the qualification of the vehicle track system, the high speed of the vehicle, and the track of the which they may operate an integral system is in the utmost importance for the vehicle track safety meeting minimal qualification criteria. Rolling stock operating in Class 6, which 1 year with the promulgation of the subpart considered qualified with the Class 6 and vehicles presently operating in Class 7 speeds. Reason for the conditional waiver shall be considered with the qualified in Class 7. The grandfathered equipment is not necessary for the railroad conduct qualification testing as described below. If the railroad operated with specified with equipment Class 6 or 7 speeds, particular level of the can't device, reason for the conditional waiver of the railroad is not required to obtain the FRA approval approval of the operation at the speed of the devices. Unless the operation is grandfathered in accordance with the paragraph A with the qualification testing may ensure that in each of the rolling stock is operated with any less speed than 10 miles an hour above the proposed maximum speed. The vehicle track system will not exceed the wheel rail force safety limits, track lateral safety limits listed in Statute 213.33, and car body lateral vertical acceleration safety limits are included in paragraph B of the section. The railroad must comply with limitation of the car body acceleration listed in the section. During the qualification phase, must comply with the car body acceleration listed in the VTI table of 213.33. 333.3 during the day of the operation of the system. For the grandfather operation of the high-speed railroad may have the result of the planning, consideration, operation practice, condition, single system road crossing the train adjacent to the track during the testing program should comply with the requirements in this section. For the operation that has been grandfathered, the report of the test procedure the result must be submitted to the FRA. The report shall also include the design of the plans, which will also be used to the VTI table of the statute 213.33 on the class 7, 8, and 8. The railroad must be submitted analysis description of the single system of the operating practice to the governing operation of high speed. The railroad cannot operate with speeds of 150 miles an hour without a rule particular applicability except that the permitted with the conducting and testing of the 10 miles an hour above its intended operating speed in accordance with this section. Unless proposed operation has been grandfathered, the Associated Administrative Safety to review the test of the result of the submission above the specific maximum speed value of the candidate device. Based on the submission, the inspector may request that the provided with the memorandum contained with the recommendation concerning the visibility of the FRA approval of the proposed higher speed operation. During the test, the railroad test engineer will evaluate the data and safe to do so and will decide the manner on run to the incremental speed and typical 5 to 10 miles an hour higher than the last run. The FRA headquarters will staff and typically provide the test monitor to observe the testing. However, in some cases, the regional staff may be called to monitor the testing, and decision will be reached. The test monitoring is not necessary for the particular test, as appropriate for the FRA technical person that may be also involved with the monitoring of the test. The passenger equipment safety standards requirement for the pre-venue of the service acceptance of the testing plan set forth the information that must be included within the test passing qualification procedure for the notification of the FRA approval of the plan. See 238.111. Specify 238.427 suspension system appendix C part 238 for the passenger equipment shall be designed to limit the lateral vertical forces acceleration to limit the indication. 213.345 track safety standards establish the testing procedure safety criteria which must be met during the vehicle qualification on high speed route as well as the material which must be submitted with the FRA consideration of approval. After the vehicle is in accordance with the statute 213.345, the other provision of the track safety standards require the monitoring of the monitoring of the vehicle track interaction with the parameters for the track 7, 8, and for tracks classes 7, 8, and 9, section 213.33.3 K requires all the instrumented car having dynamic response characteristics that are representative of the equipment or portable device that monitors an onboard instrument should operate the frequency at least twice, and within 60 days the representative car or portable device shall be mounted vertical and laterally orientated with accelerated placed near end of the car at the floor of the level. In addition, with the accelerometer shall be mounted on the truck frame. If in the car body vertical of the truck frame lateral acceleration measurements exceed those of the VTI table in statute 213.33, the train speed will be reduced until safety limits are not exceeded. 213.33L states that the track classes 8 and 9 instrumented with cars represented other than equipment assigned with the service shall be operated over the track and revenue speed profile annually with not less than 180 days between inspection. Instrumented cars must be equipped with the functional instrumented wheel set to measure the wheel rail force. If the wheel rail force does not exceed the time and not exceed the limits of the table, speed will reduce until these safe limits are not exceeded. The car body acceleration limits in statute 213.345 are set more stringent levels than those in 213.33.3. A new vehicle track system is accepted to demonstrate the compliance with the 0.3 peak to peak lateral acceleration, 0.55 G peak-to-peak vertical acceleration limits. As the system wears and changes over the time, the railroad must comply with the statute 213.333, which sets the limits of 0.5 G peak-to-peak and lateral 0.6 G peak-to-peak vertical. The car body acceleration limits are established primarily to prevent safety hazards to the occupants of the high-speed equipment, which may lose the balance or fall, but are also indicative of the track quality. An event's magnitude as well as its duration is important to take into consideration in examining occupation safety and track quality after the qualification exemption of the safety limits in statute 213.33. Further, regardless of the duration may result with the appropriate remedial action sustained oscillator car body acceleration more than concern with the single impact related event. The following type of events will consider the exemptions as in statute 213.345. B, regardless of the event duration, events exceed exceeded the instrument accuracy of the accelerator meter 0.35 G's peak-to-peak lateral and 0.565 peak-to-peak vertical. An event corresponding with the wheel rail force of the truck frame acceleration of exceeding 90% of the prescribed limit, or in the case of the vertical wheel loads, less than 20% of the static load. A sustained oscillator event which exhibits the 4 or more consecutive peak-to-peak occurrences, which are each occurrences exceed the limits within the 4-second period. For coach cars, a lateral vertical car body even event above the peak of 0.6 G's peak-to-peak vertical and 0.5 peak-to-peak lateral. For power car locomotives exceeding 0.7 G's peak-to-peak vertical or 0.5 peak-to-peak lateral within Tegahazard filter. Each of the event must be examined for its duration. See the following figure using the 50 millisecond filter for the above threshold for the applied for the use measured status signature and magnitude. The 50 millisecond criterion has been effective removing the short duration spikes, which does not affect the ride safely. Acceleration application of 50 millimeter second peak to peak time in seconds. 345.01 failure to conduct qualification testing is required. 345.02 operating class 6 above speeds without approval of the FRA associated administrative safety. Moving right along, 213.347, automotive or railroad crossing at the grade. There should be no at the grade low level highway crossing, public or private, the rail crossing at the grade on a class 8 or 9 track. In the train operation class projected with the class 7 speed, the track segmented that there include the highway rail grade crossing track. The track owner shall submit the FRA approval of the complete description of the proposed warning barrier system addressing protection of the highway traffic high speed train. The train shall not operate class 7 speeds over any of the tracks having a highway grade, railway grade crossing unless the FRA approved the warning barrier system exists on the track segment and 2 elements of the warning barrier system are functional. The application of highway rail grade crossing, public or private rail grade crossing at the grade at the prohibited with the class 8 and 9 track. The railroad must submit the approval of the FRA Associated Administrative Safety Complete Description Proposed Warning Barrier System addressing the protection of the highway traffic and high-speed trains before operating with the Class 7 speed permitted with the crossing unless the FRA approved the warning barrier system exists and all elements of the system are functioning. Railroads encouraged to install and maintain an optimal warning barrier system on crossings in Class 6. 347.01 highway rail crossing at the grade at present grade on a class 8 or 9 track. 347.02 unapproved warning barrier system on a class 7 track. Alright, 213.349 rail end mismatch. Any mismatch of the rails at the joints may not be more than prescribed by the following table. The class 6, 7, 8, and 9. Any mismatch of the rail joints may not be the following. On the tread of the rail end in 1/8 of an inch. On the gauge on the side of the rail ends 1/8 of an inch. Okay, measures when the bolts are tight. If the bolts are not tight, report the condition as of the bolt defect. Deviation of the tolerance prescribed in the statute 213.349 table constitutes the reportable exemption. Particular attention should be given to the mismatch on the gauge side. The sharpened flange of the screw truck of the combination of the bolts may cause the wheel to climb at the gauge mismatch, particularly on the outer rail of the curve. The mismatch, the vertical and lateral, extremely critical on the high-speed railroad may contribute to adverse dynamics in addition to transitional hazards. 349.01 railway mismatch to the tread of rail exceeds allowable. 349.02 railway end mismatched gauge side railway exceeds allowable.